So today now we are going to see another new topic, is a principal stresses and strain. Okay, and when we are studying this principal stresses and strain, we will also look into the Mohr circle. So this principal stresses and strain can say as a stress and strain transformation. Okay, to understand this transformation, you should understand how this mechanics of material or any body changes. Okay, so first, for an example, let's consider there is some body. There is some body. Now this body is at some axis. Okay, at some axis. Just confirm me that you can see my screen or not.
Yes, ma'am.
Okay, alright. Now this body, I'm placing it over here in that origin, this particular origin I'm considering it. Okay. Now let's consider this body is subjected to different kind of loading system. Okay, different kind of loading system. Just a second. Different kind of loading system. So when this body is getting subject to different kind of loading system, this will transform from this original plane to a different plane, from this plane to a different plane. So just a second. Different plane. So when this load is acting from this axis, let's consider initially it was x and y. After this loading system, it will change to another new plane of x and x dash and y dash, a new plane. So when there was a transformation, right, that transformation into an inclined section, right, forming a new plane, that is known as a principal plane. Okay, and when the object is transforming from one axis to another axis due to subjecting of direct load acting on a body, right, so that particular plane is called as a principal plane, where we will consider no shear stress effect is taken into consideration, where there is no shear stress effect is taken into consideration. Okay, clear? So we should understand what is principal plane and principal stress. So the plane which have no shear stress, so shear stress we define as a tau, where tau will be 0, that any plane when the load subjected and it transforming from one plane to another plane is called as a principal plane, and the load carried out by that particular due to the transformation of the axis is called as a principal or the stresses caused by to transformation is called as a principal stress. So principal stress is nothing but is the normal stress, which will denote by the letter sigma n. So this is very important. So anywhere if they're asking the principal stresses or the principal plane, means the shear stress, okay, acting on the plane will be 0 and there will be only a normal stress. Okay, now we have the lot many different types to predict or analyze the stresses acting on a body or the stress conditions. Okay, we have four different types, four types of stress analysis. Okay, we have four different types of stress analysis. So there are having four types. You have to remember the four different types of analysis. The first one is a direct stress condition. Second one is a biaxial stress condition. Third one is pure shear. Pure shear. And the fourth one is the combination of biaxial and the pure shear stress condition. Okay, so there will be a lot many different loading system. So based on the different type of loading system, how this principal axis plane will change and what will be the maximum angle, that is our motto to find in this particular topic. Okay, so basically we will see the four different phases. Okay, clear? So along with me, please note down, and whatever I am drawing, you copy that. So the concept will be entered inside your mind. Okay, so here we will see lot many of free body diagram, which we will be solving from this when the load is acting on the body. Okay, now we will move to what will happen in the direct stress. So let's consider a block. Okay, let's consider a block. So let me draw in 3D form. Okay, now direct stress means there will be a unidirectional, or I can say unidirectional stress condition. That means the load or whatever the force or the load acting will be in only in a one direction. Either it can be on the x direction or can be the y direction. It should be in any one of the direction. So suppose if the load acting is in any one of the direction, let's consider along the x direction. So let me consider that as a sigma x, right? Sigma x. If it is in the y direction, for an example, for this particular object, the load was acting, it will be sigma y, right? Since we are considering here as an unidirectional, that means load acting in any one of the direction. Okay, so what will happen if I consider from any among this section, particular sections, right? Among this section, particular section, if I consider, if I have a close look, what will happen? It will form from this particular section a normal stress will be acting at some angle. Okay, a normal stress is going to act at some particular angle, right? Now in the same case, right, this is a scenario is going to happen if it is in direct stress or a unidirectional stress. For an example, what will happen if if I'm if there is another bidirectional stresses? Bidirection means there will be having stresses occurring on two direction, both at the top y, positive y, and the negative y. So here we'll write sigma y, here also sigma y, right? Can you follow, all of you? Just let me know. Can you follow this? What is meant by direct stress, biaxial stress, pure stress, and the biaxial and pure stress? Is it clear? So first of all, let me know, is it clear, the direct stress and bidirectional? Clear?
Sigma n.
Sigma?
N.
Yes. What is the question? What is sigma n?
Yeah, I didn't get it, the concept.
Okay. The sigma n is a normal stress, right? That means, for an example, when all those sigma y and sigma x is acting, normal means if I cut along this plate, okay, along this some angle, okay, if I
Could you
cut
please
along,
just draw another cut section?
okay, let me magnify this particular part, okay.
Yeah.
So this is perpendicular which I am drawing, right? That is here, okay. This is the, so from this complete object, right, this is a complete object, right? Got it? The rough sketch. Now here I am applying some amount of sigma x, here I am using also sigma x, here I am having sigma y, here I am having sigma y. Some amount of load is acting. So what will happen, just imagine, there is a, each block consists of lot many different kind of atomic bonding structure with an other molecules, okay. Now what they will try to have some reaction. So when both the side I'm pulling each other, so there will be some, from this particular plate there will be some normal stress will be acting. So that is nothing but the normal stress acting on that plane. On what is the plane? We are taking a principal plane, we are considering a principal plane, right? At some angle, we don't know what is the angle, we need to find out the angle what will satisfy, okay. That is a concept. So at some angle where it will create an normal stresses, right, where it will create, normal means from perpendicular from the surface, right? Okay, so right, so this is for the bidirection. Similarly, for the pure shear, what will happen, there won't be any this kind of sigma x and sigma y. If this is a block, if this is the block, if this is the block, there will be only a shearing will occur across the body. There won't be any sigma x or sigma y. There will only the shear stress will occur. Only shearing will occur. That is called as a pure shear, or the pure shear stress condition. Okay, these are the conditions you just need to remember. Then comes biaxial and the shear stress condition. That means in this particular body, it will undergo both the bidirectional as well as shear stress. That means it will have some kind of shearing also. Okay, this will have the shearing. Now we will see if such kind of body undergo different kind of loading system, how their principal stress occurs. Okay, the main motto over here is to predict the principal angle. Okay, principal angle is where there won't be any plane, where we don't be having any shear stress, right? That's what we have seen. You got it? The main motto based on the different kind of loading system, what will be the principal plane deformation, or where will be the transformation of their axes from the original axis. Is it clear? Just let me know, because this is a very very important topic.
Mom, can you please tell about the principal plane once again, please?
Principal plane is a such kind of plane where the shear stress will be zero. Okay, that means, suppose consider this is a body. Now this body undergoing different kind of loading system, right? So when this body will try to change or transform to another new axis, because the body is bending or twisting, whatever it is happening, right? It will transform to a new axis, right? So that new axis we are going to find where the shear stress will be zero. Only there will be the presence of normal axis. That particular plane is known as a principal plane, and that particular axis belongs to a principal axis, where very simple, where the shear stress will be zero, right? Where the shear stress will be zero.
A normal axis will be present, ma'am.
But the normal stresses will be present. Normal stress will be present, but the shear stress will be zero. It is so, any body, when this body is subjected to any sort of loading, the body will deform or transform to another new axis. Okay, so when it is transforming to a new axis, and that particular axis no shearing is occurred, right? So basically what will happen, because of this loading, the normal normal stress will occur, as well as the shear stress will occur, right? Shear stress at some particular point will occur, but where the shear stress will become zero. So that particular plane, and what is the plane, what is the limit of the plane, based on different conditions. Okay, that is our main motto to find.
Ma'am,
Yes.
then in pure shear, then there will be no principal plane. Ma'am.
In pure shear,
there will be no principal plane, because as you said, tau shear stress will be equal to zero.
yes, you will see that. We'll see that how it occurs, right? We will see that one by one. Okay.
Because ma'am, in direct stress, biaxial stress, and biaxial and pure shear stress, we will have like sigma x, sigma y. But in pure shear, we don't have any like sigma x.
We will see here our main motto to find what is the principal plane. If there only the pure shear, right? The main motto to find how this based on the magnitude of the shear, what will be the normal stress acting, and what is a tangential stress. Tangential stress nothing but the shear stress we will be talking about.
Shear
And what is a
stress.
shear stress? the overall shear stress, then the resultant shear stress, the resultant impact, the resultant
So in
stress.
all the 4 cases will be
Yes,
concentrating on these 3 months, sigma n,
yes,
tau and resultant.
yes.
Okay, theta.
What are the resultant stress occurring? Okay, what are the resultant stress and what will be the maximum plane it can go? What will be the maximum principal stress? And when will be the minimum and what are the conditions it will be? Okay, that means we will find what, where the shear stress is 0, that is a maximum condition, right? That is what our principal plane, that we are going to find out, right? That is a motto. We will see in all the cases how this varies. Okay, we will see that.
Okay, ma'am. Okay.
Now I will start with the direct stress condition. Okay, direct stress condition. Now what I said, direct stress condition, there was a object,
Either sigma x will be there or sigma y will be there.
yes, unidirectional. So let me consider along the sigma x. Okay, now in this condition we will have different kind of let's me consider a reference plane over here. Now we don't know what is the theta value. Theta value is unknown. We are going to find out the theta value. Okay, now from this plane which is created, it will create a normal stress. Now if I magnify this particular part, we will get something like this. If this is theta, here we are having sigma n, right? From here we will be having our sigma x, right? Now since it is, we are going to take this reference, we are going to take this principal plane reference, so I need to resolve this particular sigma x, right? Now what is a theta angle? Which one is theta angle? This one or this one? Which one is theta angle? What will be the angle? The total should be 90 degree, right? What is the theta angle? You got my question? Now this is a plane, right? I am resolving this. I need to resolve this sigma x. Which one is theta? This one or this one? Which one will be the theta value?
Upper one.
How? How the upper one?
Ma'am, lower one will be the theta.
Just see, this surface is parallel to this one, right? Now this one will be equal to this one.
Yeah.
Then can I say this angle will be equal to this one? So this will be theta. This complete, this one will be 90 degree. So this cannot be theta,
Yes.
right? So likewise, even in the numericals you have to find out the theta value properly. Now what will be this value? This will be theta, sigma x cos or sine. If this is my reference plane, which will be
Cos, ma'am.
cos
Sigma x
theta,
cos theta.
and this direction will be our sigma
Sin
x
theta.
sine theta, right?
Yes, ma'am.
Now if I want to find this equation, right, let's resolve this equation and we will get can I write likewise? Can I write sigma n equals to sigma x cos theta? Can I write?
Yes, ma'am. Yes, ma'am.
Huh?
Yes, ma'am.
Yes. Okay. So this is the main equation for an direct stress condition. Okay. This is the main equation for the direct stress. Now if I consider theta is 0 degree, if I consider theta is 0 degree, what will be the value of sigma n?
Sigma x, ma'am.
Sorry, sigma x, right? So there is one more derivation, so no need to remember the derivation. There is another expression of tau y for this direct stress condition. Sigma x by 2 equals to sine 2 theta. Okay, so you just need to remember this formula. Okay, tau xy equals to sigma x by 2 sine 2 theta. Now if you have to substitute the value of theta equal to 0 over here, what is the value of tau xy?
0, ma'am.
Tau will be 0 because sine 0 will be 0. Okay, now when the theta is 45 degree, what will be the value?
So 0.707 times of 0 sigma x, ma'am.
That means sigma x equals to root over 2, something like that.
Yes, ma'am. This is the answer.
Next, tau xy will be
Sigma x by 2 root 2, ma'am. No. It is sigma x by 2, ma'am.
sigma x by 2. Now when the theta is 90 degree, you have to remember all those conditions. Okay, theta is 90 degree. Cos 90,
0.
okay, right? Tau xy equals to
0, I guess, ma'am.
yes, because this 90 sine 2 into 90 it will become 180.
Sine pi 0.
135.
Sigma n is equal to sigma minus sigma x by root 2, ma'am. Minus sigma x by 2, ma'am.
Now from this particular condition in the given problem, they will ask you that in case of direct stress condition, or they might use the term called unidirectional. Okay, so at what angle the normal stress and the shear stress will be 0. Okay, then what will be the answer?
90.
Yes. Okay, this is one of the significant term, right? When both in case of unidirectional stress condition, when both the normal and the shear stress are 0, that angle will be, the principal angle will be 90 degree, has to be 90 degree. Okay. Next is when the normal stress remains same as the unidirectional stress or the tensile stress. Okay, whatever the stress, it can be tensile, it can be compressible. Okay, so compressive stress, so whatever they give that, right, the normal stress remains same, but the shear stress will be 0, but the shear stress will be 0. So what will be the principal angle? What will be the principal angle? What will be the principal angle? Which one? What is the principal angle then? It has to be
0.
0.
Sorry.
Okay. To obtain the maximum, to obtain the principal angle, then for a direct stress, what are the angle to undergo the direct stress? Where we will obtain, at what angle we will obtain the principal stress in a direct stress condition, principal plane in a direct stress condition. What are the angle? 0 and 0 and 90
0,
degree.
180. No, 180. No, 90.
0, 180 and also 90, right? We are also getting 90 degree, also we are getting the stress is 0, right? 0, 180, 90, 360. $270 is also there, right? Clear? So they will give you the couple of options, you have to choose among them. So these, they will ask you the questions likewise.
Ma'am,
Now
can you repeat the last question once again, ma'am?
Okay, so they can ask that in case of direct stress condition, right, what will be the possible principal angle? Okay, what will be the principal angles? Principal angle means what? Where the shear stress will be 0, right?
Yes, ma'am.
So these are the possible angle. Okay, these are the significant points. The last significant points of this direct stress is the maximum shear stress should be equal to the sigma x by 2, that is tau max. So whatever the tau max, if they ask in case of direct stress condition, it has to be sigma x by 2, that is half of the
Direct stress.
direct stress. Okay.
And for this also we have to find the principal angle, ma'am.
Yes, principal angle.
44.
No. This is already known. This is already known. If they ask to find what will be the maximum condition, the maximum condition you can obtain that during this to find out the maximum stress condition is for the 45 angle. You can say that.
Okay.
Okay, because this is a condition for the maximum stress condition. You got the another significant point?
Yes, ma'am.
Right. Okay. Now, next is our biaxial stress condition. Okay, biaxial stress condition. So in this biaxial stress condition, what is happening? They will be having on two direction, right? Here, here, here and here. So along this side we'll take a sigma x and sigma y. Right? Now consider any particular cross section. Again we will split some angle theta. Here we will take the normal stress, right? So in this we will get a equation like sigma n equals to sigma x cos square theta plus sigma y sine square theta. Okay, you have to remember this equation. Sigma n equals to sigma x cos square theta plus sigma y equals to sine square theta, and tau xy equals to 1 by 2 sigma x minus sigma y sine 2 theta. Okay. And one more thing, resultant stress, you can write sigma r equals to root over sigma n square plus tau square. Okay, tau xy square. If they ask in a question that find out the resultant stress, then you will know the values of x, theta, and the sigma x, sigma y and theta values. So from that you will substitute the value of sigma n and sigma y, and from that you will get your resultant stress. Okay, now let's come to that. If theta is 0 degree, if theta is 0 degree, what will be the value of sigma n? What will be the value of sigma n?
Sigma x.
Sigma,
Sigma
yes, sigma x. What is the tau?
0.
Tau will be 0.
0.
Okay. Now next we will go for theta is 45 degree.
1 by root 2. No, 1 second.
Sigma x.
When cos,
45.
when theta is 45 degree,
Yes, ma'am.
and here we have a square, that means 1 by root 2.
Oh, sorry, ma'am. Sigma x plus sigma y by 2.
Yes, so I can write half of sigma x plus sigma y. Can I write?
Yes.
Then tau xy.
Sigma x minus sigma y by 2.
Okay. Now theta is 90 degree. When theta is 90 degree,
Sigma y, ma'am.
it will be a sigma y tau xy
0 and
0.
with theta is 135
Minus of sigma x plus sigma y by 2.
minus a half sigma x plus sigma y.
Yes, ma'am.
Then tau
So will be
square.
minus sign.
Again we have minus. Right? Now you tell me what are the important conclusion that we can bring into the picture from here.
Then principal plane at 0 and 90.
Principal plane are in the 0 and 90
90.
degree,
90.
right? And where we will have the maximum principal plane, we will have the maximum
45.
stress, maximum stress. So
Shear
maximum
stress
stress
45.
is half of sigma x minus sigma y will be at the angle 45 degree and
135 degree, ma'am.
135
Then
degree.
135 should be minimum, no? Minus of that.
See, it is plus and minus. Okay, right? Plus.
are
So
we
mostly
talking
we
about
considered
plus
that
versus-
if that option is not given, like 135 degree, you can just put on to the 45 degree. Okay, but in case they have given the 135 also, that you have to opt for the 135 because the maximum says at plus and minus. Okay, theta is also when it is plus and minus 45 degree. Okay, and shear stress is 0 at which plane? At which plane?
90, ma'am.
90 and 0.
And 0, ma'am.
90 and 0. Okay, now you can also opt they can ask this kind of questions when the normal stress is equal to the stress acting along the y direction, what will be the principal angle? Okay, next is when the normal stress equal to the direct stress along the x direction, what will be the principal angle, right? So what you have to do is you have to know how these parameters are formed and you have to remember the formula. Now in this kind of problem they can also give you the value of sigma x, sigma y and theta value, and they will ask you to find out the resultant stress, or they will ask you to find out the normal stress or the shear stress. Okay, they will give some unknown parameters of theta value apart from 0, 45, 90 and 135. Okay, understood? I hope all of you are copying these equations.
Yes, ma'am.
Okay, all right. Next we will move to pure shear. Pure shear stress. Okay, so in this pure shear, what I have shown the figure, there will be only shear. Right? So in this you have to remember the equation tau sine 2 theta and tau xy represents tau cos 2 theta. Okay, Now what will happen here if the theta is 0? Sigma n equals to 0 and tau xy
Tau.
be tau. Then sigma equals to 45 sigma n equals to next n equals to 0 minus tau 135 So here also you can come to a conclusion. In case of pure shear, it is something different, right? Pure shear, where will be your principal plane?
45 at an angle of 45 and 135.
Yes, 45 and 135. Okay, and where will be having the maximum?
0 and 90.
0 and 90 degree. Okay, 0 and 90 degree. Right, please note down this. And here also same thing. To find out the resultant, you have to find using this sigma n square plus tau xy square. Resultant stresses acting on a plane. Okay. Yes, yes.
Ma'am, could you please look into that formula for biaxial stress condition, shear stress formula? Ma'am, it is written minus of x sigma x minus sigma y by 2.
Where? Which one?
In the book.
Where? Which one?
In biaxial stress condition.
Which formula you are after? This
Shear
one?
stress formula. Yes, ma'am.
Tau xy equals to
Minus of 1 by 2 sigma x minus sigma y sin 2 theta.
minus.
Yes, ma'am.
See, in fact that minus sign varies because it depends on the derivation how they have taken it. Okay, but the fact is when you will substitute in this formula, okay, in this condition, if here comes minus and again here it will be plus, it is going to come as vice versa, right? So I don't think that will be, different textbook, it varies, different kind of conventions. Which textbook are you referring to? Can you tell me? Can you tell me the textbook?
Ma'am, Mechanics of Materials by B.C. Punya.
Okay. But that won't be a consent. That is not a issue, right? But you will get the. You can give a try for a problem. Right? Are you getting the right answer or wrong? Okay. When you solve the problem, you can just give a try. Okay.
Okay, ma'am.
Okay, and then we can understand that whether this formula is correct or not. Okay.
Yes, ma'am.
There is one more thing is there. Obliquity angle. Obliquity angle defined as phi, which defines that tau xy by sigma n. Okay. So tan phi equals to tau xy by sigma n. Obliquity angle, ratio between the tau xy by sigma n. Okay. Right. Next comes combination of biaxial and pure shear stress. Okay. So here by the name itself you can understand, so there will be a combination of both the biaxial load as well as a pure shear. So it will be something like this. Sigma n. Here we'll have the tau. So here is a combination of both the biaxial load and the pure shear. Okay, this formula is little big, so sigma n equals to half sigma x plus sigma y plus again half sigma x minus sigma y cos 2 theta plus tau sine 2 theta, and tau xy defines half sigma x minus sigma y sine 2 theta minus tau cos 2 theta. Okay, now if here theta is 0, what will be the sigma n?
It's actually is that mom, it's sigma x. Sigma x by 2, mom.
Sigma x by 2. Only sigma x by 2.
Sigma x.
Only sigma x, ma'am. Only sigma x.
What happened to the sigma y?
It will cancel, ma'am.
Yes, mom.
It will
How?
be cancelled.
Mom, it's cos 2 into 0. Cos 0 is 1, mom. And then we'll be having the remaining. So it's sigma x is the answer, mom.
Then tau xy.
Tau, ma'am.
It's minus tau.
How minus?
Stay in the formula actually.
Sine 2 theta, ma'am, 0, ma'am. So
minus is there. So it will become minus tau.
Okay, okay. Right. Okay. 45 degree. Then
Mom, it is half of sigma x plus sigma y plus tau, mom.
half of sigma x
half of sigma x plus sigma y plus tau. Half of sigma x minus sigma y, ma'am.
90°.
Sigma y, ma'am.
Ma'am, minus tau, ma'am.
Minus or plus?
Correct, correct.
Ma'am, half of sigma x plus sigma y minus tau. Yes, ma'am. Correct.
Right? So here, to determine the maximum and minimum value of direct stress, okay, in this case, to find out the maximum and minimum value of
When 0 and at 0, 90°, ma'am.
We have to use this formula here. Tau x, okay, tau by minus sigma y.
Is that tau xy, ma'am?
No, not it's a tau, this value, this tau is different, xy is different. Xy means complete this value.
Yes.
Okay, tau which is acting on the body.
Okay.
See, again it will depends on the convention. You just understand the fact this tau means which is acting on the body, and sigma x and sigma y are the direct stress. Okay, sigma n is a normal shear stress. Okay, now one more thing is there, to find out the maximum principal stress and minimum principal strain. Okay, we will have one formula. Can I change to next slide? Can I change? Just let
Yes,
me
ma'am.
know. Okay, these are the mostly problem based. Maximum, very simple formula, principal stress and minimum principal stress. So maximum we denote as, or we can also call as a major. Okay, we can also call as a major and minor. So major principal stress can be defined as sigma 1 half sigma x plus sigma y plus, right? You can take the half outside or you can keep it inside. You can, either of the way you can write the formula. Sigma x minus sigma y whole square by 2 whole square tau square. Here we denote as sigma 2 as sigma x plus sigma y 2 plus root over.
It's only tau here or tau xy square, right?
Sorry?
It's tau square only or tau xy square, no?
Tau square. See, do not get confused with tau and tau x. These are the values which is acting on the body. Okay? If you are considering the tau x y is acting on the body, then you can take it. So again I am telling you, this is acting on the body. Tau is acting on the body. And tau x and sigma n, these are the resultant value that we are component that we are finding out. Based on the stresses acting on a body, these are the component we are finding out. These are the tangential stress component and this is a normal stress component. And combinedly we can find out the resultant component. Okay? Did you get the difference?
Yes, ma'am.
Okay, so look into the question. Look, that's why I'm drawing this figure. So here the given data is tau, right? Here this is a resolving component. These are the resolving component. Okay. So whatever here also same thing. Here sigma y, sigma x, tau. Here I am mentioning tau. Okay. Then to obtain the
In the minor, ma'am, it should be of minus.
okay. Right. Thank you so much. Just thank you. Absolutely. It should be minus. Okay, it should be minus. Okay. Now another way we can write this formula. Okay. Another way we can write this formula plus sigma y by 2, and if it is minus we can keep the half outside. This is also we can write. Okay. Okay. Now another formula is there to find out the tau max. Tau max is can be found as sigma 1 minus sigma 2 by 2. Sigma 1 means what? The maximum principal stress. Sigma 2 is a minimum principal stress. Okay. So it can be written as sigma x minus sigma y by 2 whole square plus tau square. Right? Noted? Shall I change?
Yes, ma'am.
Okay. Now this kind of this whatever the principal stress acting and all those things, it can be represented in two forms. Okay, analytical form and graphical form. So graphical form mostly it has been used over here. Graphical by means of the Mohr circle. Okay, you might have heard the word called as Mohr's circle. Right. Now sometimes they will give you some equation, and from the equation they will ask you that what will be the center of the Mohr circle and what will be the radius of the Mohr circle. Okay, so this combining of this principal stress can be written in this form, can be further in this form: sigma 1 comma 2 equals to sigma x plus sigma y by 2 plus and minus sigma x minus sigma y by 2 square plus tau square. So to identify the center of the Mohr circle, okay, this defines the center of the Mohr circle, okay, and this one defines the radius of the Mohr circle. So basically sigma 1 comma 2 C plus and minus r. C represents the circle, r represents the radius of the Mohr circle. Okay, whereas just again I am telling, remember this is sigma x, the direct stresses acting on the body. This is sigma y along the y direction, and these are the shear stresses tau. Okay, so either they can give you this particular body, okay, they will give you some value for this sigma x, sigma y and tau, and from there they might ask you find out the center of the Mohr circle, or they might also represent that in a graphical way. So they will give you lot many options, and from there you have to pick the right one, that where the center location is correct. Because once you substitute the, suppose for an example, let me give you an example, the sigma x is given as 10 kilo Pascal, sigma y equals to 20 kilopascal, and tau is around 5 kilopascal. Okay, find out the center of the Mohr circle. Find out and tell me the answer. Center of the Mohr circle will be 10 plus 20.
15.
So it is 15.
15 ma'am.
Right? So 15 will be the answer. Similarly, substitute this value. If they are asking the radius, then you have to find out, substitute the value and find out the radius. Right?
But center must be given in terms of coordinates now.
See, it must be in coordinates, but when we are drawing the Mohr circle represents by the sigma and the shear stress. Okay, this is along the shear stress. So if the Mohr circle is here, right, to identify the center of this Mohr circle, it will be in terms of this same unit. That means I can locate from here to here, that whether it is in this direction or this direction. If it is 15, then that means here to here is 15. You got point?
Okay ma'am.
Okay, so that means here to here is my sigma x plus sigma y by 2. Right?
7 point something is answer ma'am for radius.
Radius.
7.07.
Huh. Okay, so that will be the radius. That means if I have to find out from distance from here to here, it has to be 7.5. Right? Okay, now I will show you. You should know the nomenclature of the Mohr circle. Okay, what are the nomenclatures you have in the Mohr circle? Just a second. So the sigma, here we have the tau, right? So let me consider circle. Just a rough I'm drawing. This may be the center. Let's consider this a center, right? This is one important point. Just give me a second. Right? So to find out here to here is your sigma 1. So what is sigma 1? Is your major stress, right? So they will give you this kind of questions can possibly come. They will give you a graphical representation, they will give you the values. From there they might ask you find out the major principal stress. So whatever the value will be here, that will be your major principal stress. If they ask to find out the minor principal stress, that means whatever this point will be your minor principal stress. Now distance between from here to this point will be the center of the Mohr circle, which is defined by sigma x plus sigma y by 2. That is the center. Radius is this much or this much. That defines what? Radius root over sigma x minus sigma y by 2 whole square plus right. If this is a point it's been given, that means is the tau max. Okay, so some of the question they can also ask the plane of maximum shear is also equals to the radius of the Mohr's circle, right? This, it is a circle, so this one and this one are going to be same. They're not going to be any much differ. Did you got my point? Did you get my point?
Ma'am.
हाँ.
Hello.
Yes.
Ma'am,
Yes.
we have written a formula like tau max equal to sigma 1 minus sigma 2
Sigma
divided
1.
by 2 into
Yes. Sigma 1 minus sigma 2.
2 by 2 into tau sigma square root
See.
of sigma x.
Okay. Sigma max we have written sigma 1 minus sigma 2 by 2. Right? Now I am telling it is equivalent to the radius. Right? So can I say right now sigma 1 minus sigma 2 equals to twice of r. That means diameter of the Mohr circle is nothing but sigma 1 minus sigma 2. Can I say? See this graphical representation. To complete from here to here is sigma 1. I am subtracting sigma 2. Will I get my radius? Are you able to get my point? Am I audible?
Yes, ma'am, you're audible.
Okay. So could you able to get this point? Another important point. Can you?
Yeah, ma'am. But tau max you have written like a sigma 1 minus sigma 2 divided by 2 into square root of sigma x sigma y by 2 whole square. Like that, no, ma'am?
See,
Yeah, ma'am. I know.
equals to.
Yeah, yeah.
It is equals to is there.
Yeah.
Okay, right? Equals to is there, and we know this value is nothing but what we have seen here. Here we have seen that value is equivalent to the radius of the Morse circle. Okay, so this can go also be written as the same. So either of the way they will ask you one or the other question from this particular concept.
Can we just hold this page for a minute, ma'am? Just
Yes, sure, absolutely.
This concept will repeat in more like failure theories also.
A bit, somewhat. Yeah.
Okay.
See, in the structures now everything is interconnected with each other, right? So some other way it will can come back. But this is a very important topic, and this structures is very much scoring. So please, you just need to remember the formula, the where you need to implement which formula. That's it. Okay, and see the connectivity. They are telling tau max equals to sigma 1 minus sigma 2 by 2. This can be also be represented as a diameter. The radius. Okay.
Yes, ma'am. Copied.
Okay. In case of pure shear, okay, in case of pure shear, the Morse circle are always like this. If I have to draw in sigma and tau, it will be always, the center will be over here at this point, okay, and the origin, and it will be equally distributed across the face, right? Can you justify this point? Can anyone justify this point? Why it happens so? Why it happens so?
Which point, ma'am?
This, in case of pure shear, we get a Morse circle something like this, where the center point coincides with the origin. Where the center point coincides with the origin.
Ma'am, generally center formula is sigma x plus sigma y by 2. But
Very
in
good.
case of pure
Yes.
pure shear, it is not there.
Exactly. So we don't have any sort of the direct stresses, right? It is will be simply 0. C will be in the here, right? And if I want to find the radius, wait, what is in the radius? Root over again sigma x minus sigma y by 2 whole square plus tau x square. Now again this term will be 0. The tau only will be remaining. So this is the radius, right?
Yes.
So we can ask you some sort of assertive and reason question. Okay, so you also should be alert about that, assertive and reason. Okay, now let's solve some of the problems based on that. Okay. Okay, let's look into this problem. Okay, that 3.13 problem. So direct stresses of 120 Newton per mm square tensile and 90 Newton per mm square compression exist on two perpendicular planes at a certain point in a body. They are also accompanied by the shear stress in the plane. The greatest principal stress at the point due to this is 150 Newton per mm square. So what must be the magnitude of the shearing stress on the two planes, and what will be the shearing stress at the point? So in this particular question they have given tensor. Let's consider direct stress under sigma x and sigma y. So sigma y is a compressive, so it will be a negative. Okay. Now they have said it is also accompanying the shear stress, but the value has not been given. They asked to find out what will be the value. The greatest principal stress has been given. So what is meant by the greatest principal stress? They have given the major principal stress, that is sigma 1 has been given, right? So how you can find? See, don't look into the terminologies they have given over here. Sigma 1 equals to sigma x plus sigma y by 2 plus root over sigma x minus sigma y by 2 whole square plus tau square. This is a formula, right? So you know the sigma 1, you know sigma x, sigma y. You can find out the tau value, right? Now you solve and let me know the answer. What is the tau value you are getting? Could you able to understand? Just unmute and let me know. Could you able to understand?
Ma'am, they have denoted the axial stresses in terms of sigma 1 and sigma 2.
That's why I said do not look into this thing. Don't look into this thing. Right? Do not look into this thing. Don't look. Okay? Just look into the formula which I have given. So what is the formula? Sigma 1 equals to sigma x plus sigma y by 2 plus root over sigma x minus sigma y by 2 whole square plus tau square. So from here you need to find the tau.
Is it 84.85 Newton per mm square?
84 point, yes.
84.85.
Yes, absolutely. Next, what they have asked, what will be the maximum shearing stress at the point? What that means, what you have to find? Maximum shearing stress means what you have to find? Tau max. And what is the tau max formula? Is either you can find
Sigma 1 minus 2.
sigma 1 minus sigma 2 by 2, but you have to find sigma 2 also, right? Instead you can simply use another formula called root over sigma x minus sigma y by 2 whole square plus tau square. Both are same, right? You can use this formula also. So either of the formula you can use and find out the answer.
It's 135 Newton per mm square.
It's 135. Very good. Yes. Now we will solve another problem. Right? Okay. Solve for the first one first. A body is subjected to a pure tensile stress of 100 unit. What is the maximum stress produced in the body at some oblique plane due to the above condition? What is the answer? All of you just respond.
Zero, ma'am. Zero.
Zero. How you are getting zero?
It's a pure tensile stress.
Pure?
Pure tensile stress, ma'am.
Pure tensile stress, okay. That means they have given here, what they have given? Sigma x has been given, okay, at some unit. What is the maximum pure stress? Okay, shear stress. That means what is a tau max in during this condition?
950.
Yes, that is sigma x by 2. 100 by 2 is 50 units. Okay. Next question. In a strained material, one of the principal stresses is twice the other one. The maximum shear stress in the same case is tau max. Then what is the value of the maximum principal stress?
Two Thomas. Ma'am, twice of Thomas.
How you got that?
It's one like Yes, ma'am. Twice of Thomas.
How you got that?
Ma'am, Thomas is equal to sigma 1 minus sigma 2 by 2.
Okay. Tau
Sigma
max
1 is
equals to sigma 1 minus sigma 2, okay, by 2.
And one principal stress is twice of the other, so twice of sigma 1 minus
Sigma 1 equals to twice of,
sigma 2.
okay. So if you substitute over here, you will get 2 sigma 2 minus sigma 2 by 2, right? You will get as sigma 2 equals to 2 max, right? But give maximum value for the maximum principal stress, right? So that means if you have taken twice of this 2 means sigma 1 equals to 2 into 2 tau max. That means you will get as 4 tau max. See, read the question carefully. They ask the value of maximum principal stress. So then what is the right answer? Option? Which option? C. Others, can you follow? Just let me know.
Yes, sir.
So See, the question is very simple. You know the parameters, but they will make you twist in this way.
Mom, can you please tell it again?
Okay. See, here they have given, it is the principal stresses. Okay, principal stresses means what? Either the sigma 1 or sigma 2. So one of the principal stresses is twice the other one. So let me consider sigma 1 equals to twice of sigma 2. Okay, sigma 1 is twice of sigma 2. Now they have given what is tau max. Tau max we know, tau max equals to sigma 1 minus sigma 2 by 2. Okay, what they asked to find the value of maximum principal stress. That means how the principal stress will be related with the tau max. Okay, that is sigma 1 I need to find. So I have considered sigma 1 equals to 2 sigma 2. I am substituting the value in place of sigma 1. So 2 sigma 2 minus sigma 2 by 2. What I will get? Sigma 2 by 2 equals to tau max. So sigma 2 becomes twice of tau max. But here they ask for the maximum principal stress. That means maximum means what? Sigma 1. Okay?
Yes, mom.
So sigma 1, but if I want to find, then it is 2 sigma 2. So 2 into sigma 2 is 2 tau max will be of 4 max. Got it?
Yes, mom.
Right. Now this. And material element subjected to a plane state of stress such that the minimum shear stress is equal to the maximum tensile stress could correspond to.
Ma'am, hello ma'am.
Hmm.
Ma'am, in the previous question, ma'am, if we take sigma 2 as 2 times of sigma 1, like that, ma'am.
Hmm.
It's
See.
another case, no, right? Ma'am?
Okay, you can take the another case, but if you are taking likewise, then they are asking the maximum principal stresses. Whatever the maximum principal stresses value you will be getting, that will be the answer. So either of the way you have to find out the maximum value, right? Both the sigma 1 and sigma 2 you have to find, and whichever is the maximum and how they are related, that is the value. Okay, you want to consider that, sorry, let me change the color. Now you want to consider sigma twice of sigma 1 equals to sigma 2, right? Am I right? You want to ask something like this? Are you asking this one?
Yeah, ma'am, I'm getting the same 4 term max only, ma'am, but the term will be another, ma'am. That is sigma 2 will be of term max.
Yes. See, if you are doing like this, okay, you have considered this way. Now you are going to find max, right? So you are taking sigma. Let me take sigma 1 minus 2 sigma 1 by 2. You are getting minus sigma 1 by 2. You are getting minus, right? Am I doing it correctly? So sigma 1 equals to minus. Okay. Now you need to find the sigma 2 also. Sigma 2 equals to 2 sigma 1. So 2 into 2 tau max. Right? 4. So here the main thing they ask is a maximum value. Which one will give the maximum value? And what will be the maximum value? What is the maximum value? So sigma 2 is giving the maximum value, so that is a 4 tau max. You got the point?
Okay, ma'am.
Okay. Solve this problem. So what is the answer for this one? So what is it? Max sigma 1 minus
Sigma 2 by 2.
by 2. Okay, or we can also take up that sigma x. So here instead of x they are given sigma 1, so by 2 whole square, right? Tau
Plus
is
2
not there,
square, ma'am.
tau is not there, so we can ignore it. So overall what we'll get? Sigma x minus sigma y by 2, right? Did you get my point? Okay, now
Yes, ma'am.
now if you substitute over here, tau max equals to, here sigma y is not there, so you will only get sigma x by 2, right, which is not. Now here max equals to, you will have sigma x minus sigma x, both are same, it will cancel up, you will get 0, right? Tau max is coming 0, this is also not working. Now here also, see this figure itself, it is not balanced, so just leave it. Now you see here we have sigma x minus of minus x, right, by 2. So sigma x by sigma x 2, sigma twice of sigma x by this, we will get, you got it? So which is the right option?
D.
D. So do you get the they will ask you such kind of problem, they will give a different kind of representation, right? So this is not acceptable one, okay? So if this kind of alternations are there, you can simply ignore that option, especially in this kind of problems, okay? Shall I skip to next?
Yes, ma'am.
Now this is another problem. The state of stress at a point in a loaded member is given as shown in the figure. The magnitude of the maximum shear stress is. So here you need to find out what is our maximum magnitude. It's a very simple problem. So in the figure, sigma x is given, sigma y is given, right? Tau xy. So here they have mentioned tau xy, means nothing but the tau which I have considered tau. Okay, which I have considered tau. So you can simply use this formula.
Ma'am,
You can simply use this formula. What is the answer? C?
yes, ma'am.
Yes, this is the answer. Oh, sorry. Yes.
Ma'am, the previous question.
Okay.
Ma'am, 1 second, the previous question.
Okay.
Ma'am, 50, ma'am.
Yes. It's 50.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Next. Let's look into the first question. In an biaxial stress problem, the stresses in the x and y direction are. They are given the sigma x and sigma y. From here, we need to find out the maximum principal stress.
Major principal stress.
Yes,
Sigma 1.
Ma'am, 150.
it is. Calculate it properly.
Ma'am, what about the tau value?
If tau is not given, that means it is 0.
Ignored.
Huh? Anyways,
Yes, ma'am.
in the biaxial
Biaxial.
stress problem, there won't be any tau. For combination only, we'll have the tau.
Ma'am, is it
Option D.
easy?
Which one?
Option D,
option.
ma'am.
200.
Option D.
Yes.
200, correct.
Okay. Okay. It's 200. Okay. So remember the basic formula. That's what you need to use. Okay. Sigma x plus sigma y by 2. Okay. Plus root over sigma x minus sigma y by 2 whole square plus tau square. Here tau is not there, so just make and negotiate this. Okay. Then the maximum principal stress for the stress state shown in the figure. This is the figure shown over here. Okay. So what will be the maximum principal stress?
2 sigma, ma'am.
Yes.
2 sigma, ma'am.
How you have found 2 sigma?
Taking the formula.
Option A, sigma, ma'am.
Sigma or 2 sigma?
Ma'am, 2 sigma.
Which formula here you are using? The same
Ma'am,
formula?
maximum principal
Same formula.
Yes. So here what is the sigma x equals to also sigma, sigma y is also sigma, and tau is also sigma,
So sigma, ma'am.
right? So the right answer is
Sigma, ma'am.
2 sigma. Just check the answer. I am having 2 sigma.
1 second.
Just check the answer. see, when you will substitute over here, you will get 0, obviously. Okay.
Yes.
Here, when you are substituting, you will be having sigma. Now,
Sigma.
when you are substituting here, you will have sigma. Sigma plus sigma, you will have 2 sigma.
2 sigma.
Right?
Yes, fine.
Okay. Now this. Which one of the following more subtle represent the state of pure shear?
C, ma'am.
Same.
Option C, ma'am.
Already we have discussed, right?
Yes,
Yeah,
ma'am.
ma'am.
It is the option C. Right. Option C. Now this.
C, ma'am.
The same question.
C, ma'am.
Exactly.
Option C,
So
ma'am.
Pure
previously,
shear.
Pure
yes.
shear.
So previously what they have said, they have just said the name, what is mean by, and here they have shown the schematic diagram. Okay. So you just know the understand the importance of the diagram. So if they are adding some kind of direct stresses, that means it will become the bidirectional and the shear stress. Then the figure will be different. Right? This represents only the pure shear. So pure shear means that is option C.
C.
Right? I think that's all the questions. Right? So now you tell me if you have any question. If you have any question, just let me know.
Ma'am, I'm just confusing with that negative sign in shear stress.
Negative?
Yes, ma'am. Negative sign in the formula.
Okay.